Thanks for coming, everybody. IoT New York meetup. So first and foremost, thanks to Datadog for allowing us to be here. This is pretty epic. Michael, do you want to say a few words?
Yeah, I'm Michael Gerstenhaber. I'm a product manager here at Datadog, and I just wanted to welcome everybody to our home. We're a cloud infrastructure application performance monitoring tool, as well as log aggregation. So we combine all of those monitoring products into one single pane of glass. And we also ingest telemetry and health metrics from the field. So the edge devices you'll hear about today, as well as the sensors in the field themselves. So we're growing in IoT. We're also growing the team. So if anything that you see interests you, or you want to work with trillions of data points per day, or you like the view, you should stick around and see if something interests you. We are also hosting our first conference this summer for building and scaling the next generation of applications, infrastructure, and technical teams. And we have a code for this meetup if you want to join us there. So we also have an iPad in the corner by the beer if you want to sign up for updates, or you can take a picture here and use that code at checkout. Thanks.
All right, another round of applause for Datadog for having us here. IoT World, this is a great event. Timescale has been there before, awesome event for us. And anyone else that's in the world of IoT should certainly think about attending. And Dory's here to say a few words about IoT World.
Thanks.
Yeah.
All right, how is everyone doing? Awesome. All right, so I'm here to invite you out to sunny California next month to attend IoT World, which is the largest IoT World event in the world and probably the coolest one. So it's May 14th till the 17th, 4-day-long event in Santa Clara, heart of Silicon Valley. We also have a code for the event, so use IoT NY, and we're actually going to do a raffle too. So we're just going to pass around a box, and if you guys drop your business cards, I want to give away a free ticket. And I also, go online, just Google iotworldevent.com if you want more info. And I have a short video too, right? So we're just going to play, and that's all.
IoT World, seriously, you guys should attend. Lastly, a partner sponsor, Momenta Partners. Ed, I'll let Ed say a few words. He's going to actually kick things off after we're finished this. But these guys are making a lot of, great moves in the hyper-focused on the connected industry, IoT and smart cities and all the rest. Thanks for being a part of this. Actually, it was Ed's idea that we have this event on IoT Day, so thanks to Ed. And then our speakers, we have, as I mentioned, Neil Cohen from Edge Intelligence and Amir from iguazio. So now we're going to do some community announcements. This is actually a lengthier kind of welcome because of all the sponsors and stuff. But also we had a lot of inbound sort of, hey, can you announce our conference? I'll kick things off. I'm Andrew Stoller. I work for a company called Timescale. We're the developers of Timescale DB. It's an open source time series database packaged as an extension to Postgres. And actually, a lot of our work early on in IoT led us to build this database for what we call the rise of the machines. Kind of all of this data that will be generated by these connected machines and devices in our world. And then everywhere else in finance and telecommunications, in ad tech. So we're hiring, things are going quite well. So talk to any one of us if you're interested in learning more. So there's a venture conference coming up this week in Jersey City. Here's a code, IoT New York, for 75% off. If anyone wants to take a picture, I think it'll be a good event. There's another conference coming up later this month. This is put on by NYU's Center for Urban Science and Progress. I don't think they liked us as much and didn't give us a code, but you can register at this URL if you have any interest in sponsoring and attending. And then Hardware Con, this is in San Jose later this month as well. And for IoT New York members, an additional 15% off the insider rate. And I think IoT New York is going to be doing a lot of things with Hardware Massive, which has a presence in New York as well. So stay tuned for that. Lastly, Data Camp. They have this promo code at the top for their premium access to data science courses. For anyone interested, head over to Data Camp. And that's it. If anyone else wants to, Jolie, you want to? Oh, okay.
Because I'm the unsung sponsor because I sponsor the video. And,
That's right. Last but not least.
And so, I'm with the local chapter of the Internet Society. Internet Society, founded by Vint Cerf and Robert Kahn, who invented IP TCP, without which you wouldn't have the Internet and you wouldn't have the Internet of Things. And we've been going 25 years. The New York chapter's been going 20 years. We deal with the Internet of People a lot as well as things, but I actually do the live streaming, and where you'll find it at livestream.com/Internet Society. In the last 2 weeks, I've done an Internet Governance Symposium at the American University in Washington on March the 30th. And in Canada, we kicked off the multi-stakeholder process for security of IoT. That happened on April 4th. You can see the whole thing on our channel. We actually have an IoT SIG within the Internet Society, iotsig.org. Thank you.
Yeah. Round of applause for Jolie, because the live streams actually come out. They're just great. And without further ado, Ed, kick us off.
So welcome everybody to IoT Day. How many people actually knew that there was an IoT Day? The few of us. There's like National Donut Day, National Pumpkin Day, but I think it's very appropriate now that we actually have an IoT Day. So my name's Ed Maguire. I'll give you if we get the technology working here, we'll look at that. So I'm an insights partner with Momenta. I'll give you a little bit of background on Momenta and the space. But what brings us here today is the concept of edge computing, which is what I'll talk about and what the next speakers are going to talk about. This has now become really the hottest topic in IoT. So a little bit about Momenta. So Momenta is a company, it's a firm. We are hyper-focused on what we call connected industry. We use the term industrial IoT because that's a much more accessible term, but connected industry really includes not just what people think of as Internet of Things, but also machine-to-machine communications and other types of connectivity. And we have three main practice areas. One, really, which is our anchor, which is an early stage venture firm. We invest in seed to A round early stage companies, and we've made around 25 investments and actually had 4 exits. We have an advisory business where we provide strategy advisory both to smaller companies but also to larger industrial and tech firms. In fact, we were the guiding hand behind the biggest IoT acquisition of 2016, which was Xylem's acquisition of Census, which is a $1.7 billion acquisition. We've also worked with companies like Vestas and Wind River, Schneider Electric, many others. So we work with traditional industrial firms and really help them connect their physical assets to IT and get more value out of it. And lastly, we run an executive search practice where we've placed about 180 executives, mostly VP level and above, but a lot of heads of sales. We've been doing a lot of work with C3 IoT, SAP, and many, many other firms. So we do have a base here in New York where we also have presence in Switzerland, London, and the West Coast. But certainly we're interested in startups. We're interested also in helping established companies. So I just want to start with a little bit of a high-level view here about this pendulum swinging between centralization and decentralization. What we see in computing is really a kind of a meta trend of the move from being highly centralized systems to decentralized systems. And the mainframe era started out where software and hardware were bundled together, very tightly coupled. We moved to the decentralized era where we had PCs and client-server architecture. We've moved to the cloud mobile architecture, or the paradigm where most of the processing actually gets done in the cloud or in cloud-based data centers, and people use maybe a mobile device as really just as the presentation layer. And now what's happening is we're starting to see disaggregation of technologies and the rise of a decentralized paradigm. And edge computing is very much part of that. So just like to back up a bit and highlight what is most important about IoT. What brings us to want to connect the physical world to IT systems, and that really is about getting business value out of data. It's not just about visibility, but what's represented here is really this virtuous cycle of analytics where you collect data, you're able to see what's happening, you're able to identify patterns and predict it. Then you're able to apply actuation and control to provide recursive reaction to the insights, and then over time learn and improve so that when you collect the data again, the cycle starts. But what analytics do is really just three simple use cases, or three simple value vectors: managing risk, creating predictions, and optimizing operations. So we know data's coming. This is somewhat cliched, but what I did want to show here is that the data that is coming from industrial systems is massive. And a lot of it is going to be used, a lot of it's not necessarily useful, but clearly the volume, the velocity, the variety, and the veracity are key, and they're overwhelming this cloud mobile paradigm. So what's happening is that we're starting to see this emergence of what's called edge computing. The traditional model that's been, or the cloud model, where you actually take data that's generated from an edge device and it has to traverse a cellular network or other network all the way back to a data center where it's processed, and then return intelligence. That just doesn't work when you're looking for real-time insights. So what we're now seeing is all of these incredible technologies that are converging, and I'm a huge believer that we're in a very special time right now because we have these exponential forces like the declines in the cost of certainly of processing and storage and bandwidth, but also the rise of robotics, autonomous vehicles, augmented reality. You have cognitive systems, blockchain, distributed ledger technologies. And what's happened is that we increasingly need to be able to process data much closer to the physical edge so that decisions can be made accurately and in real time. And customers of these systems, customers of IT systems, they don't want to have a lot of different systems that are localized, siloed. They need to be able to talk to each other. So you need to have new architectures. You need to have interoperability. You need to be able to decouple logic from physical systems and then be able to implement and apply really the business, the intent of the business and the intelligence that we're gathering from physical systems. So it's a great opportunity to invest. Actually, if you look at some of the forecasts from IDC and Gartner, IoT infrastructure, it's on a relative basis, it's not a huge growth market. They're forecasting around 11% growth through 2021. It's about a $17 billion market, but edge infrastructure is forecast to be about a 22% grower to over $3 billion. And big data analytics tools are, where we're starting to see, this is the real hot pepper. This is where we're seeing growth on a compound basis well over 30%. And there's a prediction, I think it's useful to throw around, I don't know how exactly it'll be, but 40% of IoT data will be processed at the edge by 2019. That's next year. It's coming up. So this concept of moving processing to the edge so that the analytics get closer to the physical processes is not quite as easily accomplished as it is conceived. So you have the need to bridge IT systems with traditional legacy operational systems. There are a lot of, there are environmental challenges, quite a number of them. I'm not going to walk through all of these, but what emerges when a number of the basic problems are solved is that you actually do open up a lot of new use cases and a lot of new capabilities that can be accomplished, through this architecture where you have essentially an intelligent edge. And that's this concept that's emerging now. There's a great video by Peter Levine from Andreessen Horowitz. I do recommend it. Essentially it's his manifesto where he kind of says the cloud is toast. The cloud isn't really toast, but what is emerging is this new decentralized paradigm where you want to be able to move processing, to the edge based on the business case, where have the data, have the analytics occur on the most appropriate medium or the most appropriate vehicle, delivered at the appropriate latency, and essentially be able to have the optimum performance and price based on the business needs. So the key here, again, we want to have business value. A lot of people love to talk about technology. Technologists, of course, are obsessed with solving these problems. We have these problems of moving data, processing data, managing massive amounts of storage. But the only thing that really matters is solving business problems. So when you come right back to to first principles, this is all about solving a problem, whether it's in manufacturing or transportation, in self-driving cars, in healthcare, in energy, if you're optimizing a clean energy grid, or even in oil and gas, being able to prevent downtime of pipelines. This is really a precursor, and the vision here is that ultimately, what we'll be able to achieve is a concept of autonomous systems, where data that gets analyzed or collected and then analyzed is able to be acted on almost immediately, and the ability to preempt breakdowns, hazardous conditions, to reduce risk. This is all inherent to the vision of analytics, and accomplishing this through edge computing or an edge architecture is critical. So what we'll see here is what Momenta believes, me and my colleagues there, we do think that what's happening over the next decade, and it might happen a lot sooner, is that a lot of the most critical business decisions are going to move to the edge. They're not going to be made in a centralized data center. A lot of historical analysis will be performed in data centers, but the ability, for instance, if you think about self-driving cars or fleets of autonomous vehicles, these are systems that need to be able to respond to real-time, very sudden changes in, in physical context. If you think about a cat running out in front of a car, you want to be able, how do you send the instruction to the car to brake and not to run the old lady over on the sidewalk? I mean, you have to, there will be a lot of ethics that actually come into designing these systems and implementing them. What really is interesting from a technologist perspective too is that we're actually setting up for a socket battleground, and I'll show you this in one of the next slides here. But you have devices in the edge that are dominated by the ARM architecture. You think about cell phones and smaller gateways, whereas the cloud is dominated a lot by traditional x86 and Intel architectures. There is going to be a battleground where we're seeing a lot of applications essentially sort of fighting for fighting and helping each one of these architectures find dominance. So there's a vision for where this is going, and that's this concept of hives. Actually, my colleague Jim Fletcher, who used to be the CTO at Watson IoT, is a big believer in this concept of a hive, essentially that's an aggregate, that it aggregates a lot of intelligence and works really in a collective, in a sort of a meta-intelligent fashion, where you have these aggregations of processes that are able to act autonomously, but then also share what they learn with other hives. So this idea that you'll have, large systems that are autonomous and enclosed over time will give way to essentially networks of systems that can be both, physically connected or logically connected. Essentially, this is the concept of the Internet of Things anyway, because the Internet of Things is not just a single internet. It is actually a network of networks, or an internet of internets. And they all have to do with certain autonomous systems or verticals. And this vision is just beginning to take shape. So I think there's an enormous opportunity for innovation around these areas. So I think this is, I believe this is my last slide, but what I wanted to outline here is this is the Momenta vision for what we call the edge. And I probably could have started with this, but I actually want to leave you guys with this, that edge actually means a lot of different things. You have the physical edge. So you have things, motors, pumps, turbines, engines, pipelines, automobiles. These are the hard edge. These are the physical devices that generate data. Then you have their instrumentation, the sensors, the actuators, the wireless modules that provide the communications endpoints. That's what we call the physical edge. Then the intelligent edge, I'll get to in a minute, but what we call the business core really consists of either a cloud or the data center and then business applications. So what's in between the physical edge and the business core is what a lot of people are thinking about in terms of edge computing. And edge computing, the way we look at it, is really consists of three broad buckets. One is an IoT gateway. This is really a very much a communications-oriented device. It has minimal compute, essentially aggregates data, and is typically tied into industry certifications. So it's a vertically focused device. But these are lightweight devices. You'll see these will be the types of things they'll sit on cars and buses or in cities. Then you have IoT appliances, where there are much greater resources for processing, storage, and analytics. There can be a level of virtualization and containerization where logic can move, application logic can move across different appliances. And then we have this concept called IoT point. We call them IoT points of presence. Some people call them micro data centers. If you even think about what Akamai does with their content delivery networks, they'll have these setups of servers that essentially act as really a regional data center that reduces the latency for data to get transferred from the physical edge to the core. So there's a lot going on here. We're quite bullish on it. And I would just say, we're going to be hearing from a couple of other companies that are doing a lot of work here. But look at the edge as an area of kind of, we'll call it sort of massive innovation. There's a lot of need for security, a lot of need for application logic. There's that will be kind of refactored and redesigned, and a lot of core infrastructure that's going to be rethought here. So it's pretty exciting. And if you layer in all the developments that are happening in blockchain and this trust layer that's emerging from distributed ledger technologies, I think it's pretty exciting. So thanks very much. I'm Ed Maguire. I'll pass this on.
Good. Well, happy IoT Day. I'm Neil Cohen. I'm the VP of Marketing for Edge Intelligence. Let's see, I've been in tech for a little over 20 years now. I've always worked on technology that I feel is where the market is moving. I spent time building converged voice, video, and data networks. I spent more than a decade at the forefront of content delivery and trying to develop immersive web experiences and cybersecurity. And very much like Ed spoke about beforehand, I believe that there's going to be a massive shift to edge technology, which means a lot of different things, some of which you'll learn about today. Got me to join Edge Intelligence, which is a startup company. Their R&D team is in Bristol, England, so I've taken a few trips out now, about 100 miles west of London. And our go-to-market headquarters is in Boston, Massachusetts, which is where I'm based, so sales, marketing, and North America focus in terms of our go-to-market. Well-funded startup, so we've got VC backing by Talus Capital, AME Partners, Wellington Partners. So well-funded startup attacking the edge analytics space. So a little bit going to date me here, but to reiterate some of the points that Ed was mentioning beforehand is I actually got my first job at Digital Equipment Corporation there we go. There's always a few there. And, they've got the claim to fame, wildly successful Massachusetts company. Their claim to fame was nobody's going to need a PC on their desk. We needed a PC on our desk. The mainframe moved to the decentralized model. And then what happened was internet, proliferation of browsers. Even before cloud technology, browsers were very basic. So the notion was thin browsers heavy on the back end. And then really a couple of things happened. IoT is certainly driving the decentralization trend, but applications just got more and more rich. And the devices at the endpoint, like smartphones, got more and more capable, which means that more processing power, more ability to run applications locally, so you can download things like apps on your phone, of course. But now if you look at the applications actually run inside of a browser, they're almost like applications themselves, where web pages are now megabytes in size, and more of that logic and processing capabilities is moving to the endpoint. So there is a rhyme and reason as to why the pendulum continues to swing from centralized to decentralized. And this time it's different, right? It's not just happening because the analysts are saying it's time for a shift and we're going to create billions of dollars of value in new companies. What I think is driving the shift this time is just massive commoditization of compute and storage. Both in the cloud data centers as well as in the actual end devices themselves. Every year that goes by, cheaper, more capable devices, and that is driving the ability to do more at the endpoints, which is what you're coupling and seeing with smart IoT devices, smartphones, and all things connected. The smarter the device, the more ability do you have to do processing in the device. Guess what? The more data it's going to be able to generate. Now, at the same time, the commodity-driven storage and compute is also making it possible to do things that weren't possible to do before, like machine learning and AI. So it's this virtuous circle where the commoditization of compute and storage, coupled by IoT devices being smarter, now you can actually do deep learning through machine learning and AI. It's a really exciting time. Now, the last trend that is also really turning the tide as it relates to decentralization is not necessarily a technical one, but around data privacy and regulatory concerns. So certainly on the B2B side, the C2C side, you even read about all the social media sites in the news today. I mean, people are very, very worried about where's the data live, where does it reside, and how do you know your data isn't getting collected with other people's data. There's things like GDPR, which are requiring knowledge and understanding of the data. And there's lots of different regulatory concerns where data in Canada sometimes has to stay in Canada. Data in a hospital has to stay inside of a hospital. So you've got the technology trend around latency, real-time applications, but at the same time, there's also this current going on around people are getting really, really worried about data, where it lives, and you're starting to hear more of an advocate across the industry around decentralization of data. So it doesn't matter if it's consumer or it's business. There's a lot of things that are being connected, generating a lot of data. I'm going to put a little color behind it just with some quick math here. Just having worked on content delivery for more than a decade, today there's a couple billion people connected to the internet. Today's IoT day, I believe there's now over 20 billion connected devices on the planet generating data. By the end of this decade, there'll be more than 30 billion. So you do a couple of rough math. We're now at a point where there's more than 10 connected devices generating data for every internet user, right? So me, my wife, my two kids, on average, are going to have right now 40 connected devices of phones, computers, things, and it's only going to get bigger. And when you start to think of the data that's going to get generated, you look at things like the Cisco internet reports and other things. 600 zettabytes of data is going to be generated from IoT each year. For those of you who don't know what a zettabyte is a million terabytes. So it's kind of mind-blowing when you think of how much is going to get generated from IoT devices. And the entire internet, about a quarter of the traffic by the end of this decade will be generated by IoT devices, which again is mind-blowing when you consider how new IoT is and how relatively different the data is to things like streaming video and other things that are very, very high bandwidth and very large amounts of data to stream over the internet. So the problem, and you're going to see this everywhere, is the amount of time it actually takes to transfer data. And you can tell already, I got an engineering background, so I'm a numbers person. So people say, well, how long is it going to take? And I just told you, a couple of terabytes are normal for things like a plane or a connected device. And you can see here, if you got a good connection, right, in the last mile, so assume you got 100 megabits per second, which often you don't, right? Maybe you got a low-speed DSL or you even got satellite in offshore locations. But if you got a really, really good last mile connection at 100 megabits per second, it's still going to take you more than 100 days to transmit 100 terabytes of data, right? So it's not going to work, if the model is taking your data and trying to backhaul it to the cloud. Now, the cloud providers are aware of this. And what they're trying to do is they're trying to do intelligent cloud plus intelligent edge, right? How do you do certain things in the cloud? How do you do other things at the edge? And in the meanwhile, they're coming up with a bunch of solutions where, hey, we got some software that talks from the edge to the cloud. If you got massive volumes of data, you can actually ship a suitcase and bring your data to the cloud. It's not the long-term solution, but everybody understands there's this gap between data generation and being able to analyze the data, because if it takes this long, if it's that expensive to ship it, and there's regulatory concerns, you're never going to get the value and the business insight that you need from your IoT devices. Okay, so I think over the next 5 years, we are going to see a massive change in the kind of tech edge technology that is made available for all of you. Today I think there's some cool solutions out there, but you see companies cropping up all the time. You see some of the large cloud vendors saying that they're going to invest $5 billion over the next 3 to 5 years to be able to build out the intelligent edge. You're going to see a lot more activity as it relates to what is going to happen at the edge. And I think today, what the edge architectures look like is really at its beginning, and it's in some ways edge and IoT 1.0. So I give edge technologies a thumbs up for things like being able to take data in at high rates, ingest rates, being able to process real-time events. So if your temperature drops below a certain threshold, an alarm gets set. Those types of things that are more in the control plane or in the data plane that allow you to be able to process events in real time. But the gateway architectures today, or certainly in the devices, don't have the capabilities you need in that middle part of the architecture that Ed was showing beforehand of what an edge architecture needs to be. Because today in the device or in the gateway, you're really going to get, best case, depending on the data generation and the volume of the data, a couple of hours maximum of storage. You have the ability to go and analyze and maybe do machine learning on one edge, but you can't look across all of the edges and analyze the data set from one edge, maybe from all of the factories in Asia versus all of the factories in Europe versus all of the factories everywhere. So most of the analysis has to be done today on one edge versus a group of edges or an aggregate. And then people are being forced to try to architect and try to figure out how data is going to look and how they want to analyze data in the future before they even know what the data is going to look like. The edge needs to be a lot smarter. I think we're at the beginning of this. But again, between this and the time it takes to get to a centralized cloud, we got to do a better job as it relates to being able to extract insight and make sure that people can drive the intended ROI and the business cases behind these IoT initiatives, because without that, the funding and the return isn't there. And then finally, on the stat, the sad state of the market is, despite all of the information being generated by these IoT devices today, 20 billion and counting, 90% of the data that's generated today is really never analyzed or acted upon, right? So there's a lot of work that's got to be done to be able to harvest this data, interpret this data, make sense of the data, and turn it into gold. So what we're doing at Edge Intelligence is, the big idea is, how do you distribute data analytics processing in lots of locations in a way that looks like it was in one place, right? So how do you manage and analyze data in one place, but in reality, it could locate in tens of locations, hundreds of locations, or even thousands of locations. So what we do is we automatically deploy software wherever you want to deploy the software, close to where data is generated. And it gives you the ability to store, process, and take action close to the devices. So let me give you some examples. We have some customers in a variety of industrial industries where they might want to put the software in a manufacturing site, in an airport, or across lots of airports. Retail stores, lots of retailers have hundreds, thousands of stores where they're trying to aggregate analytics at the edge. Banking branches, hospitals, oil rigs. And you don't always need to be all the way at the endpoint. Ed was talking about kind of the POP edge as well. That's very relevant as well, where people got to decide, do they want to deploy their edge on-premise in something like a manufacturing site, or based on the data volumes or the aggregation model, it might be good enough to put it in a hybrid cloud data center on Azure, on AWS, on Google, in Singapore. in India, in Virginia, in San Francisco, and take advantage of data centers that are in close proximity to wherever the data is generated. Okay, so the big idea here is distribute the data wherever you want it, manage it and analyze it centrally, appear as though it's in one location. The other interesting part about this paradigm, and as you read more and more about IoT, I've spent a lot talking about kind of like the cloud providers and the do-it-yourself deployment model. The telcos are getting into the game now too, right? So you'll read a lot of announcements and you'll see folks like AT&T, really big announcement last week on what they're doing around edge computing and what they want to do, because they've got infrastructure everywhere that their network is. They've got those micro data centers. And with 5G deployments, the towers are going to be a lot closer together. And there's an opportunity for them to be able to offer edge computing services to companies like yourself as a service. So it remains to be seen, like, who's going to actually be the winners as it relates to selling and edge computing services, and how enterprises are going to buy them and consume them. But it's going to be one of two models, right? You get it from a cloud provider, or a edge computing provider, and you deploy it yourself, or you're going to buy it as a service from the infrastructure that's offered by the telecommunication providers. So we got our hands in both, where we're trying to work with go-to-market partners on the enterprise side, but also working with some of the telcos to figure out, how do you take software like this and put it into telco infrastructure, whether it's fixed line or wireless. Now, the types of analytics that you're going to want to do, everybody wants to talk about machine learning and AI, and that undoubtedly is fantastic, in terms of being able to unlock deep insights and do things that a human can't do. But believe it or not, there are things that machines can't do that humans can do as well. At Edge Intelligence, we believe the right mix is to come up with an architecture that allows you to do three types of analytics. The first one is being able to do near real-time complex event processing, so being able to make decisions as data comes in, process them, and do automated alerting and decisioning and so forth. Being able to do distributed machine learning with algorithms. And then the last element is the human element, right? Being able to look at your data set and do things like analytical queries, reporting queries, and even forensic queries on the data that you don't know how to analyze today, but you might want to go back and look at tomorrow. Doesn't have to be literally tomorrow. It could be, days, months, or years, depending on the value of your data. So, at its core, really what we've done is we've built distributed analytics platform that can run anywhere you deploy commodity compute and storage. But what we do is those three types of processing, right? The first one is CEP processing in near real time, so being able to do things like pre-aggregate data, being able to match against conditions, so alerting, alarming, and so forth, identifying anomalies, looking at different types of results that might be temporal conditions, for example. One of the problems with machine learning today is, in order for many people to do machine learning, you've got to take your data set and decide what data you want to analyze, bring it to your machine learning platform, and then analyze it. Right? And what I just told you beforehand is there's a problem with moving data because the data are so heavy. Right? So it's a big problem to try to figure out how to do machine learning, real machine learning across edges in this kind of architecture. And our belief is to be able to do distributed machine learning across edges by never having to move the data. Our technique, or one of our techniques to do that, is using MATLAB extensions for SQL and then running Pivotal R on top of it. And then the human element to it, right? So some of our patented IP actually lies in some of our ability to extract data from a SQL database, where we started with Postgres. We've got our own patented protected underneath. So everything you can do in Postgres from the outside, but looks completely different on the inside. And this is where some of the magic is. So what I'm showing you here is about 16 to 18 queries of the types of analysis you might want to do on your data beyond CEP, beyond machine learning. And what you can see here is the green line is edge intelligence. So anything above it is bad, right? Time slower, orders of magnitude slower. And the reality is that most databases, even the autonomous ones today, are designed to do something very well while sacrificing the others, right? So for example, you can see that the red, which is Hadoop, does a wonderful job at acquiring data at very, very fast rates. But it's very difficult to get the data out for things like reporting and analytical queries, right? And then if you look at something like a row store, you can see that a row store is very, very good for forensic activities, but stinks for analytical queries. And then you get the converse for column indexed and row indexed types of databases, right? So without knowing your data structure and how you want to analyze data, you want intellectual IP that gives you the freedom to be able to extract the data and make sense of it beyond your machine learning and beyond your CEP processing. Structured and semi-structured data is an interesting one where we can do things to make data look semi-structured by tagging it, importing legacy data into the system. But the irony is that NoSQL was actually very, very hot for a long time. It has lots of good use cases and purposes, but what you've seen is NoSQL data is increasingly looking more and more structured or semi-structured. So our flexibility to be able to give us the metadata, give us the context, and then pull it into a SQL database is a very powerful way of combining the structured versus the sort of structured, if you will. The other thing that's important is being able to work in a DevOps environment and being able to work with the tools that you want to work with, right? So, a lot of the cloud providers are trying to lock you into their infrastructures, use our tools, use our systems, and that might not be where you want to be. So we've tried to build in a way that's as agnostic as possible, where we really don't care what BI tools you use for data visualization, so things like Tableau, Looker, Periscope, Click, they're all your choice. You have a command line interface to be able to do things if you're a SQL nerd and want to do it that way. There's nothing wrong with that, right? And being able to use standard languages like R over MATLAB is a very powerful way that people are comfortable with doing machine language. And then being able to work in a DevOps workflow, so people don't want to have to go and deploy software at all the endpoints, right? Imagine having tens, hundreds, or thousands of endpoints. You want all that to be updated automatically. You don't want to have to worry about managing software on the endpoint. So we actually use Ansible as our DevOps tool to be able to deploy and manage software in the distributed system, and then being able to import data from the legacy systems and the silos. So let me talk a little bit about some use cases and some examples before I wrap it up here. The first use case for IoT is what I call connected asset tracking using cameras and sensors. This is actually a proof of concept that we've built to demonstrate the power of distributed analytics, and we've gotten a lot of interest across a variety of different use cases for this deployment. I heard somebody mentioning smart cities beforehand, so I felt like I had to talk a little bit about where society is moving, the kinds of things you'll be able to do with IoT. First thing I should point out is this is simulated data. There's no real names on my slide and all that kind of stuff, so the 2 billion data captures are random. I'm not picking on an individual, and data privacy has been preserved. I always start the slide that way. But if you were to do an IoT deployment, remember I told you our developer team is in Bristol, England, and try to capture data across every camera and every sensor in the 10 biggest cities in the UK, as well as the entire motorway network, that system would look like about 2 billion data captures a year. Okay, so you're collecting about 2 billion data captures a year. And you'd have to be able to scale up to support about 40% of that in London, right? Because population and so forth. Now, I was hoping that the team would deploy their systems in the UK area. For some reason, to make it hard and demonstrate the performance of the system, they decided to put some of the data in India, some of it in Australia, and some of it in the US. So they actually picked 11 countries and 5 continents to distribute the data to show that the data really can live everywhere, but still be able to manage and centralize it as one. And with those 2 billion, still being able to map the entire IoT system on very efficient AWS EC2 instances with a maximum of 8 core systems. And we use Tableau for the demo. I'd be happy to show anybody, the full demo. I was advised not to run demos beforehand for tech issues. But what can you do with this? Right? I think the first thing that's very useful for something like this is transportation. Right? Connected fleet management and being able to look at where are your assets, where's your transportation, where's your freight, all the things around transportation, logistics. I mean, this is almost real-time insight that's going to give you very, very detailed in terms of your assets and where things are. So fleet management and transportation is one of the biggest categories of industrial IoT and where some of the early adopters and use cases are going. The second use case that is very interesting from this is forensic type activities, right? So there's bad actors and things. And remember how I said beforehand, you really don't know what data you need today and what data you might need tomorrow. So if you throw the data out or you reduce the data and move it somewhere else as a fraction of the data set, you might lose the data you actually need. So the example here is being able to store at the edge all of those 2 billion captures and say, hey, I want to go back and look 300 days ago and see what this car with this license plate did and what route it took across the motorway network, and be able to extract that value and get the information very, very quickly. Right? So the example here is a forensic type of work that would be very useful for things like law enforcement. Right, now the last one that we've heard a lot of interest around use cases are smart cities and energy efficiency. Right? If you know the car, you know the make, you know the year, you can estimate the carbon emission. And by doing that and being able to look at this over time, what you're doing is you're getting a blueprint that allows you to figure out where can you expand your roads, what kind of construction can you do in things like airports, and it allows the cities to plan their infrastructure in a way that's very data-driven. Okay, so some examples of IoT and smart city deployments. Another example of connected asset tracking, is not just cameras, but your smartphones, right? So your smartphones are also collecting data through GPS technology. So we have a massive scale deployment at the edge. It's storing more than 1 petabyte of data, and it's been in production for more than 2 years. And it's more than 100 million subscribers, and being able to scale up to hundreds of millions of subscribers, and being able to store data for many years to be able to go back and analyze that data. So it's an example of how I see the edge evolving from what it is today to what it could be in the future to do a lot more than real-time processing. That's important, but also being able to understand and keep your data in a way where you always can't backhaul it or reduce it to the cloud. So before I wrap up, I know the focus today is IoT Day, and I got my connected wearable and all the other things on, and I gave my refrigerator a hug this morning before I left Boston. I just wanted to point one thing out, is edge computing is very much driven by IoT, but it's not only driven by IoT. Analytics are pretty much everywhere in everything you do in your business for what you sell, and I know how frustrated many of you are. I am when I log into a portal and I'm trying to get my analytics for the service that I've contracted for, and I see a gap for like a day and a half. And I say, hey, where's my analytics? Why don't I get it now or real time? Well, the reason you don't get it now or real time is because you're buying a SaaS service and they've got a decentralized data problem where they've got hundreds or thousands of customers with lots of data that has to centralize, that they got to get into a portal and extract value so you can understand it. Right? Edge computing and decentralized analytics is very prominent today in software as a service, in telco infrastructure, and I'm just pointing out, one of our customers in the security space, when you buy managed security, you don't want to wait a day to find out if there was a data infiltration on your network, right? And you also don't want to find out that you lost your data when you want to find out and do forensic activities that occurred 6 months ago. right? So there's a lot of things that are happening with edge computing services at scale, at millions of records a day, or even billions of records a day. IoT will get to that kind of scale and performance requirements in the next couple of years, but there are a lot of other use cases that are taking advantage of edge computing today that I think are further along in terms of the use cases, the performance, and the scale that are necessary to drive real ROI, like software as a service. So that's what I got today. I look forward to speaking with all of you, and if you have any questions outside of the event, you can email me at neil.cohen@edgeintelligence.com. Thank you so much.
Cool. We'll be taking questions at the end, so hang on to your questions.
So I think we got a lot of context already. I'll try to get a little bit more into the what and the how with a little bit more technical detail. How many of you are data geeks, like data scientists, data engineers, software developers, just kind of technical people? All right, so kind of an interesting mix. The rest are just sort of already checked out, I guess. My name is Amir Halfon, and I've been sort of in the data field for a while. I was a field CTO at Oracle, and then worked with a bunch of NoSQL data platform providers. Today I'm the VP of Strategic Solutions at a company called Iguazio, which I'll talk about a little bit. For now, let's just say that this waterfall is the iguazio fall. That's what the company is named after. And when we're talking about all this volume, velocity, veracity, blah, 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 of lots of big data, that's kind of where the company got its idea for naming. And if you haven't been there, it's actually a really amazing fall. It's actually bigger than the Niagara, so highly recommended. We talked already a lot about moving stuff to the edge and all of that, but before we even go there, right, a lot of what we're talking about has to do with data, right? Which is why I asked how many of you are actually data people. And it's both in terms of analytics, but certainly when we start to talk about data science and machine learning. And if we look at big data and data science today, typically there's this sort of data lake architecture, right, where we get the data from all these sources, we add some historical context, and then kind of dump it in the lake. And the lake could be HDFS or S3 or a bunch of those type of stores where you just kind of dump everything and then do sort of offline analytics and build your machine learning models. And this is a little bit like the research and development workflow that as software engineers, we do a lot. But the thing is, when it comes to data science, I heard somebody say we're sort of where software engineering was about 15 to 20 years ago. When it comes to all this notion of iterative, agile development, right? And taking those machine learning models and then deploying them back to where the decisions are supposed to be made. What we heard a lot about that in the previous two talks. That's still basically a huge software development lifecycle, and it's very kind of waterfall-ish. And a lot of times you take those models, you give them to another team, they go ahead, they build the software in a completely different platform, it gets moved, and so on and so forth. So there's still very far from this notion of agile kind of data science and analytics. And then, of course, right, so this is what we're trying to get to, right, is continuous integration and continuous delivery, even when it comes to data science, right? So we get more agile, more sort of iterative model building and the ability to sort of react to the changing world and change our models, right, and deploy them out to the edge. But again, it's this notion of the intelligent edge that makes this even worse, in a sense. This slide is stolen from Microsoft. I don't know if they get the trademark on the intelligent edge or not, but I think now it's becoming kind of an industry term. And we heard a lot about that. And it's sort of like this confluence of a lot of things. We were talking about the compute power and the abundance of data and the notion of AI and machine learning that makes all of this possible. And there's also the notion of serverless computing that is adding to all of that. But the idea is that we want to move decision-making to the edge, not just analytics, not just being able to generate alerts, but to actually respond to events and take decisions based on machine learning models that we've analyzed and developed based on the long kind of history. So we want to have these kind of two separate layers, the sort of speed layer and the context layer, right? With the context layer being all the history and the speed layer being the sort of the event processing layer, right? Which we actually heard about also in the previous presentation. And today, these are many times two completely different platforms. Again, so it even adds to this complexity. Where we want to get is to have one platform that can actually address all of this. And essentially, this is what iguazio is sort of all about. Before I talk about it, though, this gives you a bit more kind of detail on the complexity of what it actually means to architect-driven application that is sort of connected, right, to a bunch of event sources, captures those sources, enriches the data with context, then persists it to the data lakes where you do your development of machine learning models, right, that then go out being deployed so that you have your scoring engine, right, that takes those models and scores the data that comes, right, from the devices to give you those dashboards and intelligent decision making at the edge. What happens in reality is, everybody needs one of those slides, right, in every presentation, because it's so typical to a lot of accidental architectures that grow organically. And every time we deal with, because they're like a new, now I don't like the term paradigm shift, but right, a new sort of problem space, typically this is what happens. Right? We started with Hadoop-based architectures, then we added a bunch of NoSQL, we added some stream processing engines and so on and so forth. And before you know it, we have a very, very complex set of data pipelines. And we make that agility even more impossible than before. So one solution is what iguazio is set out to do, is to actually not build yet another database with another set of APIs and another programming model, et cetera, but build a data platform, which does have a database engine underneath, that actually exposes existing APIs. So whether it's Spark data frames, Kafka streams, Kinesis, S3, DynamoDB, all those tools that you're already using, whether it's in the cloud or on-prem, are actually supported already from the tool. And that means that the same code can live in your laptop, on-premise, on the cloud, without having to change different from different engines, and without moving the data between different engines. And this is where a lot of times the complexity comes in, right, as we saw. We'll talk about a little bit of use cases also. Just to say a few more things about how we did it with iguazio. One of the key challenges, as I'm sure you can imagine, is performance, right? Because you're dealing with lots of data that comes with very, very fast. And the existing database technologies that we have today are not really cutting it. A lot of them are actually developed and engineered with the thinking that is basically 30 years old of disk is very expensive and disk is very slow, so we need to copy the data over and over and over, from the file system to cache it over at the operating system to cache it at the database layer and so on and so forth. What we did at iguazio was just to completely condense that, and we actually built everything on Flash, which is a lot faster and gives you almost the comparable performance to an in-memory database, but at about 1/10 of the cost. And because it's working on that technology, it's what's called a zero copy database. So you don't have to continuously cache the data. We just, at the query processing layer, we have the indexing structure that points directly to the location where the data lives, directly to flash memory. And that allows us to do all of this sort of stuff, and allowed us to also add very granular security and policy engine on top of the database to address some of the challenges that we were talking about before. So basically, we took all of this, all of those different types of stores, right? Columnar, stream, time series, object, file system, so on and so forth, and created a multi-model database that sort of exposes all those different access mechanisms. So you can do everything in the same multi-indexed environment. So I'll give you just a little bit more about the company, and then if you want to hear more about it, just come talk to me afterwards. It was founded about 3 years ago. Now it's already about close to 100 employees, closed Series B of funding, and quite a few deployments already out there. Obviously, industrial IoT is one of them. This is what we're talking about today, but also financial services, telecommunications. And interestingly enough, the whole area of cybersecurity is becoming quite hot, as I'm sure you know, and is starting to look a little bit like the IoT world in the sense of, again, streams of a lot of data that you're looking to analyze and to find anomalies using machine learning in. But this is a more typical use case, and this is one of our customers in Asia. It's probably the biggest Uber competitor out there. And being a relatively new company, they did everything on Amazon and used the Amazon data services. And it was working fine for a while, but then they wanted to start doing this sort of real-time analytics, real-time decision-making. One of their first requirements that got them to look to change was that they wanted to do dynamic pricing. So they wanted to change the price dynamically. If you as a driver are close to a bunch of customers, they wanted to give you a promotion, for instance, so that you wouldn't drive home. You take more customers. If you're a customer next to the drivers, you'll get a discount. It's kind of like what Uber does with search pricing, but on the other side, which is a little bit more nicer to customers. When they tried to do that with the existing infrastructure, and that was, in the Amazon side, ingesting through Kinesis, dumping the data at S3, doing some stuff with Dynamo, doing a bunch of other stuff with Hadoop and with EMR and with Redshift and so on and so forth. And it took about 2 hours just to assemble the data, just to get the data to a point where it can be analyzed. The analysis wasn't what's taking the time. It was the data pipeline. And we were able to bring it down to 2 seconds. And it's that order of magnitude that I think you actually need to achieve in order to be able to get to that point of really doing things at the edge. We see a very, very similar problem space when it comes to, again, if you're talking about transportation, handling the telematic data, whether you're talking about autonomous cars or just fleets of cars and trucks that are moving around. Again, it's a very, very similar problem where just the data ingestion and the data pipeline and the data lifecycle is where a lot of the problem lays. This is a different sort of problem space, and it's not so much IoT. It's trading, and this is one of the largest trading stock exchanges. And this is about trade surveillance, and this is about market analytics. But again, in terms of data volumes and in terms of being able to do things sort of in real time and take decisions as trades are being made, it's not different. And the challenge there was very similar to what you saw in the beginning slide. There was a data science, there is still a data science team, but what they didn't have was the ability to take their models that they developed and deploy them to the live system that does trade surveillance in a sort of iterative fashion. So what they were using was the system that was there for many years. That was essentially a rules engine, and they took what they've done, gave it to another team that then went and deployed that onto a completely different environment using a completely different scripting language, and that took a lot of times. And again, it means that there was no way to continuously respond to the market. In their case, this is a very fast-changing environment where you're kind of looking for unknown unknowns, right? You want to look at unknown market manipulation schemes. You want to look at unknown conditions. And so that was something that drove the decision to move from that sort of legacy environment to an environment where you could do both the analysis and the automated decision-making with the same environment. These guys are actually sort of in the IoT space, but interestingly enough, one of the first things that we're looking to do with them is not so much related to that, but more actually related to supply chain. And again, supply chain is very much part of the industrial IoT, but what we call forward supply chain also has to do with bringing things into the point of distribution, right? Not just actually assembling everything, but actually getting the goods in front of the customers at the right time. And when this gets a bit more sophisticated, you're starting to look at things like, I want to see when the customer is looking at something based on their location and start to integrate camera feeds and things like that. But even at its most basic, just being able to respond to the fact that the inventory changes over time throughout the day, and that I wanted to be able to do things not just the next day, but I want to be able to move the analytics and decision making closer to the regional data center rather than the sort of centralized cloud is kind of very similar here. That sense that instead of shipping something the next day, I can actually get this store to move something to another store, doing what's called transshipping from store to store. So it's a lot of those new business ideas that become enabled, and this is to go back to what Ed was saying. He was talking about optimizing operations, reducing risk, and that's very much part of the business drivers. But another one that we're seeing a lot is actually generating more revenue, right? And this is certainly pertinent here as well. I think in the interest of time, I'm going to skip a couple of those. This is an interesting one since I mentioned that, and we are actually at Datadog. So this is part of what they do as well when it comes to IT operations analytics, right? And again, the notion of IoT here is basically just an extension of the on-prem data center. One of the interesting things is when we talk about edge computing, right? If the cloud is sort of the public cloud and the data center is sort of your private cloud, the data center is essentially where the edge begins, right? And those devices and servers and so on are basically the beginning of the edge. And it's the same kind of problem, whether you're looking at the health of the data center and the health of those devices from an operational analytics perspective, or if you're looking at cybersecurity analytics and I want to see what users are actually doing with all those devices and do anomaly detection to find the bad actors before they start acting, assuming they're already penetrated, and I want to get them before they're starting to do reconnaissance based on the fact that this is an anomalous behavior that I'm seeing on the network. Again, this is the sort of stuff where you need to move a lot of decision-making power close to where the data lives, and you need to do that, basically with zero delays. The model of moving everything to a centralized cloud starts to break away. I think with that, we're going to go to the next section of the panel.
Thanks everybody for staying here. Thanks a lot. And happy IoT Day, right? Let's give a hand to the IoT New York. crowd, and also Datadog for putting this all together. So we went through all these presentations, hoping to leave questions for the end, and I know the questions you guys have are going to be a lot more intelligent than anything that I'm going to ask. So anybody want to ask something?
Hi. So my question is, you talked about legacy operation systems, and I think those are a big challenge for a lot of companies. They weren't built to do data analytics, to pull that data out. And you talked a little bit, you mentioned them, but how does, sorry, let me check I wrote my question down, but let's see. So with the legacy systems, how does that kind of interface with what you're doing, or how does IoT come into that or connect in with that, or do these systems get sort of replaced?
No, that's a great question. So I'll answer very quickly, which is that when you have, for instance, if it's a manufacturing machine or an air compressor, a lot of times what you may have to do is attach sensors or do a retrofit to get data. Some of them, some machines are built to generate data, but what's a challenge in operational technology is that the data structures and the types of data are very often in proprietary data formats. So they need to be normalized, they need to be cleansed. In a sense, it's not that much different from any other data source that you might find in an enterprise application or an enterprise IT system, but it does have to go through a process of cleansing and normalization so that it can be placed into a format so that it can be essentially turned into business context. So that's a huge part of the process. And operational technology protocols, many of them have been written not designed to be open and interoperable, but they've been designed to be essentially siloed systems. So it's a challenge, and I think it's a big part of the process. I don't know. Do you guys have any thoughts on that?
Were you asking specifically in the industrial context, or more operations, like as in an enterprise, like CRM and that kind of stuff?
I would say both. Yeah, I would say both. I think it's an issue. I've seen it in HR systems. I've seen it in crew management systems. I've seen it in a lot of different kinds of systems. So it just sort of comes in, and it's a challenge now for any sort of analytics that you want to do.
Yeah, absolutely. That's for sure. I mean, we're seeing that as we have been seeing that as a challenge. I agree. I think the same notion of moving to kind of this data-driven analytics workflow applies to both, whether you're talking about the new world of ingesting IoT data or the old world of ingesting a bunch of tables from SAP. They could both be handled by the same sort of platform. But of course, you're right, with legacy, it's a lot harder to get, organizations to change. So if you already have an enterprise data warehouse team and they're used to doing things a certain way, that's a lot of times where the challenge is rather than the technology.
I mean, I think normalization is a big problem. I think, I was going to ask the same question. Do you mean legacy data from enterprise systems or IoT, which maybe isn't as legacy, but in some industries like oil and gas, it actually is. So it's a big problem, but what we do see is that a lot of the systems that have been architected over the last couple of decades are SQL-based, right? So Oracle, Microsoft, IBM, you can go to a cloud-based warehouse like Redshift or something, and there are things to do to get the data out of that, reformat it, move it into their SQL database. It's kind of why, the approach we've taken, which is, how do you leverage the experience and the data structures that people have in the past, so that, if it is based on that type of structure, how do you get it into a system from SQL to SQL? That's pretty well understood. It's the other protocols that need a lot of normalization.
Yeah, I'll be really quick. I think I could just extend that conversation around interoperability. As you develop your systems or continue to scale your products and solutions, do you see it as a responsibility to help with that conversation around how data standards could be developed? Because I think there's still yes, it can be sector oriented, but I see a lot of B2C, B2B sort of integrations now beginning to happen because, essentially with the whole smart city conversation is all about having different innovations happening within a community, within a city, yet being able to integrate with each other. So I'm just curious on how many layers you're operating. I mean, there's security conversations, there's privacy conversations, there's formatting conversations. Where do you draw the line? Where where does your company say, okay, this is outside of our area?
I mean, I'll take a first crack at that one, but I was out in San Francisco 2 weeks ago at the IoT Build event, right? And they had all the big tech companies talking about interoperability at all the different layers, right? So there's Microsoft, there was Intel, all the chips, all the software, all the device manufacturers, and there's a whole bunch of consortiums out there that are trying to normalize protocols from the physical level all the way up to the application level. It's an understood problem. Unfortunately, a lot of the bigger companies in tech have their own agendas, in terms of, hey, if we're a hardware manufacturer, that's normalize the software. And if we're a software manufacturer, that's normalize the hardware. As a startup company, my candid answer is, we are trying to let the bigger tech players normalize the industry. We realize it's a problem, but in the meanwhile, we're looking for go-to-market partners on the SI and integration side that can handle the dissimilar protocols and work it while the standards get sorted out.
Yeah, we're a member of the IoT Consortium, and that's probably the biggest industry group that is trying to tackle that problem. So we're active in that, and as you were saying, as a startup, there's a limit to how much you can do there, but certainly we're big believers, like I said before, in working with existing protocols as opposed to inventing our own, for sure.
Sure. Could you talk about the how the different technologies relate to each other in the sense of the difference in infrastructure, connectivity, network requirements? So, like, for example, in terms of the stack, is edge computing built off of a mesh, or what are the requirements to have a successful edge solution that is differentiated from, say, something else?
That's a great question.
Yeah.
And there is no one size fits all, I'll tell you. At least some of the clients that we're working with are really trying to figure this out. What I can say is that, as you saw, and by the way, I forgot to mention that we post all of this. We posted the slides to our edge computing webinar on the Momenta website, and I have a webcast as a blogging. So please, everybody who wants to have this content, happy to send it to you, happy to share it with you. But the reality is it's mix and match, and it's just like the industry. You have to pick the right technologies, the right connectivity, and then the right application logic to solve a particular problem. And right now, there is no standard. There's no x80, there's no Wintel, there's no x80, there's no ARM that's dominant in anyone in space. So I think what you have to do is you kind of flip the script and you look at what is the specific industry use case, whether it's an application or whether it's an industry, and then build the stack appropriately that way. And that's actually it's tough. That's actually a lot of the work that we're doing at Momenta is helping our clients figure this out. So it's a fantastic question. I don't know if you guys have any thoughts on that, but I would just say, it's an open field opportunity, and certainly, because there's no standards, it's anybody can win for sure.
Yeah, I'll give you my 2 cents on top of that. I think what you're saying is layers of abstractions on top of that. So whether you're talking about the infrastructure platform being Kubernetes and Docker and so on, that's one layer. And then the data processing layer above that also can abstract a lot of the locality of where is the workload actually running. So I see both of those kind of working together. The traditional approach of you're either in the Amazon sort of platform or in the Google platform or another platform doesn't work for most people, right? So everybody's looking to abstract that away, and whether you're doing it at the data platform or below at the infrastructure platform, in both cases that's where most of the interesting technology discussions are happening.
Question?
Yeah, so what's an event without mentioning blockchain? We talk about IoT, we talk about AI and ML and everything else. Where does blockchain fit into all this? Thank you.
Wow. Well, we did, you know, in the we did talk about it as a, you know, as a trust layer. I mean, I think ultimately, you know, blockchain is foundational technology in a decentralized world, and when you are pushing out these powerful edge devices. And these devices need to have identity assertions made. There needs to be validity of data, security of transmissions, and execution of contracts. Ultimately, smart contracts. You know, blockchain technologies are going to be what enable a decentralized trust layer. That's foundational to the scaling of a multi-billions of devices that end up being connected. And you know, blockchain itself, I mean, we know that there are issues with you know, transaction times for certain public blockchains, obviously, like you know, Ethereum and the Bitcoin blockchain are not necessarily inherently designed to scale, you know, hundreds of thousands of transactions a second, but the directed acyclic graphs, the you know, IOTA. Kevin, are you still here? I guess there's, yeah. So Kevin's from IOTA Foundation. They're doing some amazing work, and you know, Hedera Hashgraph is another one. But there's some really they're joined at the hip, put it that way. And you know, we're at Momenta. You know, we've been very excited about the potential there. We've actually done a couple of webinars to educate people on the potential. It's still early technology. I mean, we're in proof of concept stage, but I you know, would like to, you know, I'm a big believer in the potential, but I'm certainly not going to bet on any one horse yet as a winner. I think we're very much early stages. But supply chain, you know, payments, provenance, decentralized energy grids. There's so many use cases that are you know, on both permissioned and permissionless blockchains. This is, you know, it is foundational. That's all I'd say.
One of the interesting things, again, totally agree, foundational, and I'm glad somebody mentioned blockchain because it always comes up. But you know, I think one of the big problems in IoT data is not just the protocols and the different layers, but trusted data sharing, right? So if you look at hospitals in the US today, you know, the largest hospital network is maybe 100 to 200 hospitals, but you have a lot of hospitals that have one or dozens or less than 100, right? So if blockchain can be used as a trust model, what I do think we'll see is things like federated data sharing, where you'll have a trusted model to be able to start aggregating data sources across different corporate entities for the benefit of society, because your data set plus your data set plus your data set equals something even better. So I've heard a lot of use cases that Ed's mentioning, but I do think with the trust model and the capabilities of blockchain, you know, the concept of federated data sharing might allow more people to get better use of the data that actually exists versus those that want to hold on to it.
Yeah, the maybe more cynical answer is, at the end of the day, blockchain is just a distributed database. It happens to be encrypted, and the main novelty about it is that everybody agrees to use exactly the same technology and the same protocols all over the place. You could achieve what we did with blockchain with actually much more mature technology, but what actually drives the innovation is just the fact that everybody agrees to the same standards, so we could do things like non-repudiation, et cetera, et cetera. And so I like what you said about the trust layer. I think we're seeing that as one of the primary use cases. So if you think about like something like a Microsoft Active Directory, right? A distributed database that holds identities and allows your organizations to do things like single sign-on. I think we can see certainly that as one of the use cases for distributed ledger technology in this sort of world of IoT. Of course, there's many others.
So just to add to that, actually, it's kind of funny. My cousin is in high school, and he he went to one of these websites, I think it's Burst or Storage. And so you're seeing now that they're utilizing blockchain to be able to go ahead and store the actual data in different people's computers. So it's just interesting to see that at the edge now you're seeing, you think about Airbnb and what's going to compete with Amazon and those companies out there is you're going to see a lot more of that opportunity for data to be stored at the edge. So have you guys run into that at all where you're starting to see like the edge is starting to eat the cloud in these sort of solutions?
That's Peter Levine's view, right? Yeah.
I like how you said it, the edge is eating the cloud. I think you mentioned that too, right?
Well, you know, what really happens, I mean, I think what's emerging is that there's, the edge paradigm is going to be, it will begin to predominate. But listen, we're still using mainframe computers that are older than all of us that are still in service. So what happens with these technology architectures is they do tend to get layered on top of one another. It's not a zero-sum game when a new technology comes in. And I think this is a misperception that investors have often, or observers in the space will see the bright, shiny object, the BSO, and say, oh, wow, okay, well, that means I have to toss everything else out. But the reality is that, particularly in enterprises, job security for people who maintain these legacy systems creates a very powerful inertia force that ensures that the other point is if it ain't broke, don't fix it, right? So these industrial companies that make up the connected industry, or they're pretty smart actually. They're almost like they're from Missouri, right? They're the show me state. You think you got this great? Okay, show me. So they're not the early adopters of technology. What they are, they sit back, they wait, they assess the risks, and they adopt the technologies once they can prove the ROI, once they know that it benefits their business, and they end up being kind of the late mainstream, but the true validation of technologies. So I think the way we look at what's happening right now is we've got a bubbling layer of some amazing innovation that of course captures most of the attention and excitement in the media and public imagination. But our client server systems, our mainframe systems, and the mobile cloud paradigm will be with us for decades. And all of these new paradigms are going to build on each other. And hey, we'll see what happens. Now, market caps, when you're talking about publicly traded companies, that's a very different story because those are forward looking. But I think we want to think about everything as being additive. We are building digital edifices. If you go back to what our civilization used to do in the years of in the era of the ancient Greeks and the Romans, like we go look at the Parthenon and the Colosseum. I mean, those were built for the people of the day, but they've lasted for generations. What I hope to see, I don't know if if the Bitcoin blockchain will be that way, whether an operating system will be that way, whether Windows operating system will be that way, or whether some of the the IBM mainframe systems will last for 100 years. But this is our opportunity to create edifices that last. So we think about design principles, and I could go on for a long time, but I'll pass that on, and we go on to wrap things up here. So thanks everybody. I appreciate you all staying here. And again, don't forget to go to the Momenta site and sign up for our webinars and blogs and good stuff. And thank you so much to Datadog, to the crew at Timescale DB, who without this.
Matthew and Michael from Datadog, big thanks. You guys are awesome.
Ajay and Andrew from Timescale, you guys are awesome.
Thanks, Ed.
For keeping the faith.
Yeah. Thanks for coming, guys. Really appreciate it. Get home safe.
Thank you.